everyone, this is Student X. In today's video, we're going to use Excel to work with real interest rates and inflation, and we'll see how purchasing power changes over time. We'll tackle multiple payments, timing effects, and even use GoalSeek to solve a tricky interest rate question. Let's get started. So for question 1, we have that annual deposits over 15 years in arrears, and this is how our payments are structured. Our money interest rate is 9% per annum, our inflation is 4% per annum, and now the question is asking us to find the present real value of the investment. Now, in order for us to find the present real value of the investment, we need the real interest rate. And in order to calculate that, we simply use the formula 1 plus I. In this case, I is our money interest divided by 1 plus inflation, and then we subtract 1. And we get a real interest rate of approximately 4.808%. That is our real interest rate. So now after that, I'm simply going to put in my time column, right? My time in years. And I know that it's going to start from 0, move to 1, 2, 3, up until 15. And the beauty about Excel is that it has this ability to identify patterns. So all I need to do is make sure that I highlight all the cells, and then I simply hold and drag up until I get to year 15, you see. After my time in years, I'm going to put a column for payments. I'll just abbreviate it to PMT. And in this case, we know that the structure of each payment is simply 5,000 plus 300 multiplied by the time in years. In this case, for this cell, it's multiplied by times 0. I press enter. And then, of course, all I need to do is drag all the way down to time 15, and it's going to copy that formula all the way down. So I know that at my cell year 15, I know that's just 5,000 plus 300 times the year 15. And then after that, what's very important is that we need to include our discount factor, you see. So in order for us to have the true present value, we need to make sure that we discount each and every payment. And in this case, our discount factor is simply going to be bracket 1 plus our real interest rate. And don't forget to cell reference or to fix the cell reference. So check at the top of your keyboard and click F4. This ensures that whether we drag left, right, up, or down, that particular cell will be referenced for all other cells, you see. And I'm going to raise that to the power of negative time, or negative t, right? And then when I drag and drop all the way down, everything is done appropriately. Now look what happens if I don't cell reference. So I input the exact same formula, but without tapping C4, or without fixing. I'm going to the power of negative time t, and this is what I have. Even though the first cell is correct, when I drag and drop, this is what I end up having. Notice how something happened here. And the reason and what has just happened here is that notice how also the cell over here moves down as you drag down. You see, now when I do this, you see, it drags down as well, instead of fixing at that particular real interest rate. That's why it's so important we use self-fixing whenever necessary. So I'm just going to clear the contents, and then after that I'm going to have a column for my discounted cash flows. I'll just abbreviate it as CF for discounted cash flows. And now my next column is discounted cash flows. I've abbreviated it to CFs. And in this case, it's simply our payment at a particular time multiplied by its corresponding discount factor, you see. And then all I do is that I just drag and drop up until year 15, you see. So now each cell has the time value of money for each corresponding payment at a particular time or at a particular year. And now in order for us to find the total real value, all we need to do is have a column for our present value, right? And then after that, we just sum everything up. So in this case, I'm going to say equals sum, and I'm going to highlight all of my constituent cash flows, and I'm going to press enter. And now this is the present real value of the investment. And I noticed that if you calculated using your 9% only, then your present value would represent the present monetary value of the investment. In other words, the value of the investment without considering inflation. So it's very important which interest rate you use, because it will give you different values for different purposes of what you're trying to find. So it's very important that you understand which interest rate you're using. If it's monetary interest, you're going to find the monetary value. If it's real interest, then you're going to find the real value of the investment. Now on to question 2, we have something slightly different. We have 40,000 deposited at the end of year 5, 70,000 deposited at the end of year 7, and we know that the investment matures at year 15 and inflation is 5% per annum. And now it says that the target real value at year 15 is equal to 200,000. Find the money interest rate required. Well, first of all, let's start with this. First of all, question 2 is not your typical find the present value, find the future value type of question. Instead, it wants you to work backwards, you see. So what we're going to start off with is a sort of a dummy variable or a dummy number or a guess number for our money interest rate, you see. So in this case, we know my money rate. We'll just say it's 10%, just for the sake of the question. And then we have our inflation, which we know is 5%, right? That's 5%. And now from this, we know that our real rate is simply going to be equals 1 plus I, or 1 plus our money rate, right? Divided by 1 plus our inflation, which is 5%, all of that minus 1. And this is our real rate, you see, which is approximately equal to 4.762% per annum. And the reason why I'm bothering with finding the real rate is because our target real value at year 15 is 200,000. So we need to work with the real rate. So after that, I'm going to have a column for my time in years. We know that that starts at year 0, moves to year 1, year 2, year 3. And as usual, Excel has this ability to pick up patterns. So I highlight all my cells and then I just drag all the way to time 15. After that, I'm going to have a column for my payments, you see. And in this case, our payments don't have a specific structure. Instead, we're given what our payments are. So at time 5, I'm going to insert 40,000. And then at time 7, I'm going to insert 70,000, you see. And then after that, I'm going to have a column for discount factor, right? Because in order to find the present value, you need to find the discount factor, you see. And in this case, I'm going to say equals 1 plus I, in this case, my real rate. Don't forget to fix, as explained earlier, to the power of negative time. In this case, it's 0. And then I want to drag this all the way down to the bottom, you see. And that is what we have. Afterwards, now I can find my discounted cash flows. You see discounted CFs, right? And then that is simply the discount factor multiplied by the payment. In this case, since our cells are blank, it'll just be given as 0, right? And then we drag all the way down. So now I know, something happened here. And usually when you have an error like this, you shouldn't necessarily panic. Sometimes it just means you just need to do a little bit of debugging. So in this case, I'm going to, instead of cell referencing, I'm just going to manually type it in, 40,000. So it doesn't give me the problem, you see. And then this here, I'm just going to say 70,000, you see. So sometimes Excel does do that. When you try to multiply, add, subtract, sometimes you do get these errors. But in some cases, sometimes you just need to try a different route. And in this case, I'm just going to manually type it in. And then afterwards, this is what I have. And then, of course, I'm going to have my present value, right? My present value. And the present value for the investment is simply the sum of the constituent time value of money components. In this case, it's just a time t is equal to 0. So that is equal to sum I'm going to add all my numbers up, and this is my present value. But notice here, the question says the target real value at year 15. It didn't ask for the time value of money at time 0, but at time 15. So all I'm going to do is I'm going to have another column, and I'm going to say accumulated value, you see. And then all I'm going to do is I'm simply going to accumulate this present value up until time 15. So I'm going to say my present value time 15 multiplied by my accumulation factor of 1 plus the real rate to the power of 15, or to the power of time t is equal to 15. And that is my accumulated value, you see. Alternatively, you could have created an accumulation factor column instead of a discount factor column, because with discount factor column, you should not forget to accumulate back or to accumulate forward to time t is equal to 15. It all depends on what you most comfortable working with. So once we have this, we're not done yet, you see, because what we needed to find is the money interest rate required. So here we're going to use a special tool called Goal Seek on Excel. So all you need to go is to go to data, right over here. After data, you go into what if analysis, and then we tap Goal Seek, right? And in this case, we instruct what the Goal Seek needs to do. So Goal Seek is basically some sort of approximator, or it uses numerical methods to find a particular value of interest. So in this case, I specifically want to set this cell M27, and I want it to be equal to the value of 200,000, you see. And the reason why I'm setting it to 200,000 is because that's what the question is asking for, you see, or that's what the question has given us, that at time t is equal to 15, the accumulated value is supposed to be equal to 200,000. You see, forget about what this number actually is. This doesn't necessarily matter. We've only picked this number or used this number so that we could work with Goal Seek, you see. And then of course we want to change, and the cell that we want to change is this cell over here, because that's what we're interested in. We are interested in finding the particular money interest rate that will change the accumulated value to give the 200,000 that the question is asking for. We press OK, and then after approximation, this is the answer that we get. We get a money interest rate of approximately equal to 12.417% per annum. And there you have it. Real interest rates, inflation, and timing solved properly using Excel. If you have a different way of solving this or another Excel question you want me to cover, drop it in the comments below. Special thanks to IJ Beats for the background music on this video. Check out his Christian instrumentals via the link in the description. Don't forget to like, subscribe, and hit the notification bell. And I'll see you in the next video with me, Tutor Next. Simplifying success, one question at a time.